Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the practice questions on multiples, factors, and prime numbers. If you need any extra help on multiples, factors, and prime numbers, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video numbers 216, 220, and 225, they're the video tutorials on factors, multiples, and prime numbers. Alternatively, you can scan this QR code and that'll bring you to the videos and worksheets section, and you can scroll down to these video numbers. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. So question number 1 says, write down 5 multiples of 3. So 5 multiples of 3, well, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, adding another 3 would be 12, and adding another 3 would be 15. Now it just says write down 5 multiples of 3, so you could write down 300, 333, 3 million, 600, and so on, but I've just gone for these multiples, 3, 6, 9, 12, and 15. Okay, let's look at our next question, question number 2. So question number 2 says, from the list of numbers, so we've got this list of numbers, 7, 9, 12, 21, 23, 30, 36, and 45. And part A says, write down the multiples of 7. So let's consider the multiples of 7. So the multiples of 7 are 7, 14, 21, 28, 35, 42, 49, and so on. And if you know your 7 times tables, you'll know the multiples of 7. So let's look for these numbers, the multiples of 7 in this list. So we've got 7, so let's write that down, 7. We don't have 14, we've got 21, so 21's there as well. So 7 and 21 are both multiples of 7. 28, no. 35, no. 42, no. 49, no. So the multiples of 7 in this list are 7 and 21, and that's it. Okay, let's look at part B. Part B says write down the multiples of 5. So from this list of numbers, write down the multiples of 5. Now this time, rather than writing down the multiples of 5, I just know that the multiples of 5 end in either a 0 or a 5. So we're looking for numbers that end in a 0 or a 5. So no, 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 yes, 30 is a multiple of 5. 36, no. 45, yes. So there's 2 multiples of 5 in our list. They are 30 and 45. Okay, let's look at our next part, part C. Part C says write down the multiples of 12. So the multiples of 12 are 12, 24, 36, 48. Now we don't need to go any further because 45 is the largest number on our list and we've gone up to 48. So we're looking for the multiples of 12, which are 12, 24, 36, and 48. So 12's there, fantastic. Next, 24, no. 36, yes, that's there. So that's a multiple of 12 as well. And that's it. So they're the multiples of 12, 12 and 36. So that's it. So we've done that question, question number 2. Okay, let's look at our next question, question number 3. So question number 3A says, write down 2 multiples of 4. So the multiples of 4 are 4, 8, 12, 16, 20, and so on. Now I'm going to write down 2 multiples of 4. I'm just going to write down 4 and 8. Now you could have written down any multiple of 4. You could have written down 400, 4 million, 8 million, and so on. I've just written down 4 and 8. Okay, part B. Part B says write down 2 multiples of 9. So the multiples of 9 are 9 times 1 is 9, 9 times 2 is 18, 27, 36, 45, and so on. I'm going to write down 2 multiples of 9. I'm just going to write down 9 and 18. They're the multiples of 9 that I'm going to write down. Okay, and then part C. Part C says to write down a number that's a multiple of both 4 and 9. So we've written down some multiples of 4 here, and we've written down some multiples of 9 here. I'm actually just going to move these down, so I'm just going to move them down here for the moment. So I'm just going to move the multiples of 4 there, and the multiples of 9 I'm just going to move there. Now if we have a look at these, we're looking for a number that's in both of these lists, a number that's both a multiple of 4 and 9. So if we carry on the multiples of 4, we've got 20, 24, 28, 32, 36. And as you can see, 36 is in both lists. So 36 is a multiple of both 4 and 9. Now you could have written down another multiple of 4 and 9, perhaps for 72 or 3,600 and so on, but I've just written down 36. Okay, let's look at our next question, question number 4. So question number 4 says, write down all the factors of 16. So remember, factors are the numbers that go into another number exactly without a remainder. So I'm going to think of the factor pair, so the numbers that multiply together to give us 16. So 1 times 16 is equal to 16, so that means that 1 and 16 are both factors of 16. 2 times 8 is equal to 16, so that means that 2 and 8 are both factors of 16. And also 4 times 4 is equal to 16, so that means that 4 is a factor of 16. So the factors of 16 will be 1, and I like to put these in order, 1, 2, 4, 8 and 16. So 8 and 16. So they're the factors of 16. Okay, let's look at question number 5. So question number 5 says write down all the factors of 26. So the factors of 26, let's think of the numbers that multiply together to give us 26. So 1 times 26, 2 times 13, and that's it. So the factors of 26 will be 1, 2, 13, and 26. You can divide 26 by all of these numbers exactly without getting a remainder. 26 divided by 1 is equal to 26. 26 divided by 2 is equal to 13. 26 divided by 13 is equal to 2. And 26 divided by 26 is equal to 1. So they go into that number exactly without a remainder, so they're all factors. So question number 6, we've got a list of numbers here, 3, 5, 7, 9, 11, 15 and 24. And part A says write down a factor of 12. So a factor of 12 will be a number that we can divide 12 by without getting a remainder. Now you could write down all the factor pairs that multiply together to be 12, such as 1 times 12 and 2 times 6 or 3 times 4, and then find it that way. Or you could just look at the list and see which ones are factors. For instance, I know that 5 is not a factor of 12 because if we divide 12 by 5, there'd be a remainder. It doesn't go in exactly. 12 divided by 7, would there be a remainder as well? 12 divided by 9, no. 12 divided by 11, no. These numbers are bigger than 12, so they're not going to be factors. 3. If we have 12 and we divide it by 3, the answer is 4. So it means that 3 is a factor of 12. So 3 is a factor of 12. Okay, part B. Part B says write down a factor of 28. So again, we're looking for numbers that we can divide 28 by, and they will go in exactly, so without a remainder. So 28 divided by 3, no. 28 is not in the 3 times tables. 28 divided by 5, no, it doesn't end in a 5 or a 0, so 5 is not going to be a factor of 28. 7. 28 divided by 7 is equal to 4. And 28 is in the 7 times tables. So 7 is a factor of 28. Let's just check and see if there's any others. 9, no, because 28 is not divisible by 9, because it goes 9, 18, 27, 36. 11, no, because it's 11, 22, 33. 15, no, because the multiples of 15 are 15 and 30 and so on, so 28 is not divisible by 15. And 24, no, there'll be a remainder. So 7 is the factor of 28 from this list. Okay, on our next part, part C. Part C says write down a factor of 81. So a factor of 81, so a number that we can divide 81 by and not have a remainder. So starting with 24, no, 81 is not going to be in the 24 times tables, because if you wrote down the multiples of 24, they'd all be even, and 81 is odd. 15, no, because the multiples of 15 are 15, 30, 45, 60, 75, 90, and so on. So 15 is not going to be a factor of 81. 11, no, because that would be 11, 22, 33, 44, 55, 66, 77, 88, so no. 9, yes, 81's in the 9 times tables. 9 times 9 is equal to 81. So it means that 9 is a factor of 81. So 9 is a factor of 81. So yep. And also it's quite useful to know your divisibility tests here. So for instance, if you want to check and see if a number is divisible by 2, or if 2 is a factor of it, then it will be an even number. If you want to see if it's divisible by 5, we've talked about that already, it'll end in a 5 or a 0. If a number is divisible by 9, then the digits in the number will add together to be a multiple of 9. 2 plus 8 is equal to 10. 10 is not divisible by 9, so 9 is not a factor of 28. 8 plus 1 is equal to 9. So that means that 81 is divisible by 9 because the digits add together to be a multiple of 9. So 81 will be divisible by 9. Okay, 7. Well, 81's not in the 7 times tables because 10 times 7 is 70. So then it goes 77, 84, and so on. So 81's not divisible by 7. 5 ends in a 1, so it's not divisible by 5. And 3. Well, 81 is, if it's divisible by 9, it's going to be divisible by 3. And also there's a divisibility test for 3. If you add together the digits in a number and they add together to be in the 3 times tables, then the number is divisible by 3. So for instance, 1 plus 2 is equal to 3, and 3 is in the 3 times table, so 12 is divisible by 3. 2 plus 8 is equal to 10. 10 is not in the 3 times tables, so 28 is not divisible by 3, so that means that 3 is not a factor of it. So 81, 8 plus 1 is equal to 9, and 9 is divisible by 3, so that means that 81 is divisible by 3, so that means that 3 is a factor of 81. So that means that our answers could be 9 or 3. You could have written down either of those. And also you could check it using the bus shelter method if you wanted to. 81 divided by 3. How many 3's go into 8? 2. Remainder, that's 6, or remainder 2. And how many 3's go into 21? That's 7. So you can check and see using division to see if a number is a factor because there won't be a remainder. And that's it. Okay, let's look at our next question. So question number 7. Question number 7 says write down all the prime numbers between 10 and 20. So it's quite useful to know the prime numbers off by heart. So the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and so on. And I've stopped there at 19 because we're looking for the ones that are between 10 and 20, so we don't need to go any further. So a prime number, remember, is a number that's only divisible by 1 and itself. So it's got exactly two factors, 1 and itself. So all of these numbers, they're only divisible by 1 and itself. Okay, so we're looking for the prime numbers between 10 and 20, so they're going to be 11, 13, 17, and 19. So 11, 13, 17, and 19. They're all the prime numbers between 10 and 20, and that's it. Okay, question number 8. Question number 8 says, write down 4 different factors of 56. Now in this question, we don't actually need to list all the factors of 56, we just need to find 4 different ones. So the easiest one I'm going to go for to begin with is 1 times 56, because 1 times 56 is 56. That means that 1 and 56 are both factors of 56. Okay, now we need 2 more factors, so I'm going to try now. It's an even number, so 2 times 28. So 2 and 28 will both be factors of 56. So 2 times 28. So they're both factors of 56. Okay, now let's try some other factors. So 3, well, 56 not in the 3 times tables. I know that because 60 is, and then if you go down 57 and 54, so 56 isn't in the 3 times tables. Or also you can check 5 plus 6 is 11, and that's not divisible by 3, so that's not divisible by 3. 56 isn't divisible by 3. 4, well, 56 is even. Let's see if we can half it and half it again. Half of it is 28, and half of that is 14. So yeah, 4 times 14. So 4 and 14 would have been other factors that you could have used. Also, 5, no, that's not in the 5 times tables. 6, well, to be divisible by 6, it has to be divisible by 2 and 3. We know it's divisible by 2, but not 3. 7 times 8 is equal to 56. So they're also factors that you can use. And now we've got 7 and 8, we know we're done here. So the factors of 56 are 1, 2, 4, 7, 8, 14, 28, and 56. And we just need to list 4 of them. And these are the 4 that I listed. Okay, question number 9. Question number 9 says, Frank says that all prime numbers are odd. And Gemma says that 1 is a prime number. And we have to give a reason why each child is wrong. Okay, so let's start with Frank. Frank says that all prime numbers are odd. Well, the prime numbers are 2, 3, 5, 7, 11, and so on. Now, it says that all prime numbers are odd. Nearly all of them are, but this one, the first one, isn't. 2 is even, and it's a prime number because it's only got 2 factors, 1 and itself. 1 and 2, they're the factors of 2. So 2 is a prime number, and it's even. So let's explain that. Okay, so I've just written down that 2 is even, and it's a prime number, so that means that Frank is wrong. Okay, now Gemma says that 1 is a prime number. Now, it's not on our list, so that means she's wrong. Also, 1's not a prime number because it has to have 2 factors, 1 and itself, whereas 1 only has 1 factor, so it's not a prime number. So let's explain that. And that's it. I've just explained that 1 is not a prime number as it only has 1 factor, whereas prime numbers need to have 2 factors, 1 and itself. And that's it. Okay, let's look at our next question, question number 10. So question number 10 says, a football team wears shirts numbered 1 to 11. So 1 to 11. I'm just going to write those down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And the question says, what fraction of the team wear a shirt with a number that is prime? So we're looking for the prime numbers here. So the prime numbers are 2, 3, 5, 7, 11, and so on. So there's 1, 2, 3, 4, 5 prime numbers in that list out of the 11 numbers. And the question says, what fraction of the team wear a shirt with a number that is prime? So it's going to be 5 11ths, 5 out of the 11. So that's it. So 5 11ths of the players, or 5 11ths of the team, wear a shirt that has a prime number on it. So that's our answer, 5 11ths. Okay, let's look at our next question, question number 11. So question number 11 says, here's a list of numbers, 80, 95, 135, and 185. And the question says that one of these numbers is a multiple of 45. Write down the number. So let's write down the multiples of 45. So the multiples of 45 are 45. Adding another 45, well, adding 40 is 85, and then adding the 5 would be 90, so that's 90. Adding another 45, well, adding 10 is 100, and then we've still got another 35, so that's 135. And then adding another 45, well, adding 40 is 175, and adding the 5 is 180. And that's enough, really. So here are the multiples of 45. They're 45, 90, 135, and 180. Now, I done that mentally, adding on 40 and 5, or 5 and 40, and so on. If you wanted to, you could use column addition in this question, do 45 plus 45, get the answer, which is 90. Then do 90 plus 45, that's 135. Then take that and add 45 using the column method, and you'd get 180, and so on. So we've been asked to write down the number that is a multiple of 45 in this list. So 80's not, 95's not, 135 is, and 185 isn't. So that means that 135 is the multiple of 45 in that list. Okay, let's look at our next question, question number 12. So question number 12, it's a calculator question, so that's quite nice. And we want to write down prime numbers between 50 and 60. Okay, so to find the prime numbers between 50 and 60, I'm just going to write down the numbers between 50 and 60. Now, it doesn't say inclusive or not, but I'm just going to write down 50 and 60 anyway. I know I'm going to be crossing them off, so then that doesn't really matter. So 50, 51, 52, 53, 54, 55, 56, 57, 58, and 59, and 60. Okay, so I've written down all the whole numbers between 50 and 60, and I've included them. Now we're looking for the prime numbers. So first of all, I'm going to rule out any numbers divisible by 2, so any even number. So 50, 52, 54, 56, 58, and 60. All of those numbers are even, which that means that 2's are factors. That means that those numbers are not prime. Okay, now I'm going to cross off 55. It's divisible by 5. Now I'm left with 51, 53, 57, and 59. So we've got 4 possibilities here. Now, let's see which of these numbers, we've checked to see which of them are divisible by 2. Now let's try 3. So 3, so if a number is divisible by 3, the digits in the number will add together to be a multiple of 3. So here, for instance, 51. 5 plus 1 is equal to 6. So that means that that number, 6, is in the 3 times table. So that means that this number is divisible by 3. That's a calculator paper. So you could take 51 and divide it by 3, and you'll see that that's equal to 17. So 51 divided by 3 is equal to 17. So that means that 51 is an odd prime number. It's divisible by 3. 53, well, 5 plus 3 is equal to 8, and that's not in the 3 times table, so 53 may be prime. 57, well, 5 plus 7 is equal to 12, and 12 is in the 3 times table, so that means that 57 is divisible by 3. And again, you can check that in your calculator. You could do 57 divided by 3, and that's equal to 19. So let's cross that one out. Okay, next, 59. Well, 5 plus 9 is equal to 14. That's not in the 3 times tables, so that means that 59 is not divisible by 3. 4, no. 5, no. I'm checking the other factors here. 6, no, because it's even. Okay, now let's try dividing both of these numbers by 7, and if you do that, you'll get decimal numbers for both of them, so they're not divisible by 7. 8, no. 9, no, they're not divisible by 3, so they're not going to be divisible by 9. 10, no. 11, no, that's 55. And you can carry that on, and you'll find that 53 and 59 are both prime numbers, and that's it. And that's it. So if you carried that on, you'd find that 53 and 59 are the prime numbers. They're the prime numbers between 50 and 60, and that's it. Now, this was a calculator question. So there is actually a technique you'd use using your calculator, which would be quite useful here, and it's called product of primes, or prime factor decomposition, it might be called on the calculator. So on your calculator, if you type into 53 and press equals, and then you go into the calculator and you go through the different modes and you can find product of primes, and it would write down all the prime numbers that are factors of 53. It would write 53 as a product of primes, and I'll just come up with 53, and that tells you the 53 is a prime number, and the same thing for 59. So that's a technique that would be quite useful for you, and if you want to, get your teacher to show you that. Okay, let's have a look at our next question, question number 13. Okay, so question number 13, we've got this list of numbers, 6, 10, 11, 16, 24, 30, and 40. And part A says write down a multiple of 20, so we just need a multiple of 20, so 20, 40, so 40 is a multiple of 20, so I'm going to go for 40. Okay, now let's have a look at our next part, part B. So part B this time says write down a factor of 12, so not a multiple of 12, a factor of 12. So the factors of 12 are 1 times 12 is equal to 12, 2 times 6 is equal to 12, and 3 times 4 is equal to 12. So the factors of 12 are 1, 2, 3, 4, 6, and 12. So we're looking for a factor of 12, so 6 is a factor of 12, so 6 there is a factor of 12. 10's not and 11's not, so the only factor of 12 in this list is 6. Okay, and then part C. Part C says to write down a prime number. So remember the prime numbers are 2, 3, 5, 7, 11, 13, and so on. Now we've got a prime number here, 11. 11's a prime number, and that's it. And it's the only prime number in the list. So that's it. So we've done that question in question 13. So part A, a multiple of 20 is 40. Part B, a factor of 12 would be 6. And part C, a prime number would be 11. And that's it. Okay, let's look at our next question, question number 14. So question number 14, we've got another list here, 15, 16, 17, 18, 20, 22, 24, and 29. And part A says to write down a prime number. So 15 is not prime, 16 is not prime, 17 is prime, so I'm going to write down 17 as a prime number. 18, 20, 22, and 24 are not prime numbers, they're all even. And 29 is also prime, so you could have written down 29 as well. So 17 and 29 are the two possible prime numbers. Okay, part B. Part B says a factor of 30. Okay, so let's consider the factors of 30. That'll be 1 and 30, 2 and 15. Oh, there's 15. 15 is a factor of 30. So that's it. So 15 is a factor of 30. And actually looking at this list, that's the only factor of 30 in that list, because the factors of 30 would go 1, 2, 3, 5, 6, 10, and then you've got 15 and 30. So 15 and 30 are the two largest factors of 30, and 30 is not on the list, so 15 is the only factor of 30 there. And then part C says write down a multiple of 3 that is even. Okay, so let's consider the multiples of 3. So they're 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And I've stopped there because that's gone past all the numbers in the list. So we're looking for a multiple of 3. So let's look at the multiples of 3. I'm just going to circle them. 15 is a multiple of 3. 18 is a multiple of 3. 24 is a multiple of 3. They're all on this list here. 16 is not, 17 is not, 20 is not, 22 is not, and 29 is not a multiple of 3. Now we're looking for one that's even, so I'm going to cross off 15. So we could have 18 or 24. So 18 or 24. Either of those would work. Now in this question I've written down 17 or 29, and here I've written down 18 or 24. If I was doing this as a question, I would just write down one of them. I'd write down a prime number, a factor of 30, and a multiple of 3 that's even. I wouldn't write down 17 or 29. I'm only doing that because obviously these are video solutions, and you may be watching this having written down 29, or someone may have written down 17, and I want you both to know that you're both right. Okay, question number 15. So question for number 15, we've got this rectangle, this box, and we've got some numbers inside the rectangle: 2, 3, 7, 9, 11, and 13. And part A says, from the numbers in the rectangle, write down a factor of 35. So the factors of 35, well, that's 1 times 35, 5 times 7, and I think we're done there. So from this rectangle, 7 will be a factor of 35. So 7 is a factor of 35, and it's in the box, it's in the rectangle. Okay, part B says to write down a number that's not prime. So 2, let's write down our prime numbers. There are 2, 3, 5, 7, 11, 13, and actually I can stop there because that's as high as the numbers go inside the rectangle. So 2, it's prime. 3's prime. 5, it's not in the rectangle. 7's prime. 9's not prime. And then 11's prime and 13's prime. So 9 is a number that's inside this rectangle that is not prime because it's divisible by 1 and 9, but also by 3. So it's got more than 2 factors. So it's not prime. Okay, let's look at our next question. Okay, let's look at our next question, question number 16. So question number 16 says, circle the number that is a multiple of 6 and a multiple of 10. So it needs to be a multiple of 6 and a multiple of 10. So in this question, you could list the multiples of 6, so the numbers in the 6 times tables, and the multiples of 10, so the multiples of 10, so the numbers in the 10 times tables, and find the number that's in both of those lists and then circle it. Or you could check and see if 10 and 6 are factors of these numbers. So for instance here, 50 is divisible by 10, but it's not divisible by 6, so that number would not be in the 6 times tables. 66, well, it's a multiple of 6 because it's in the 6 times table, so 6 is a factor of 66, but 10 is not a factor of 66 because 66 doesn't end in a 0, so that wouldn't be in both of the lists. Okay, next, 100. Well, 10 is a factor of 100 because 100 is divisible by 10, but it's not divisible by 6. So 6 is not a factor of 100. So that means that 100 is not a multiple of 6. It wouldn't be in the 6 times tables. We go 60, 66, 72, 78, 84, 90, 96, 102. So it's not that one. So hopefully it's going to be 120. Now that is a multiple of 10 because it ends in a 0. In terms of a multiple of 6, well, actually thinking about this, 6 times 20 is equal to 120. Or remember we got to 96, 102. So then it would be, so we had 96, 102, 108, 108, 114, and 120. So that would be in the 6 times tables. So that means that 6 is a factor of 120. So that means that 120 is a multiple of 6. So 120 is a multiple of 6, and it's a multiple of 10. And that's it. So we're going to circle that one. Okay, let's have a look at our next question, question number 17. So question number 17 says, write down a factor of 80 that's between 11 and 19. So in this question, you could approach it in different ways. One approach is to just get your calculator and do 80 divided by 11, 80 divided by 12, 80 divided by 13, 80 divided by 14, and so on, and just divide 80 by all of the numbers between 11 and 19 until you find one of the numbers where it's just a whole number answer. So there's no remainder, there's no decimal. So that means that that number would be, the number you divided by would be a factor of 80 because it's gone in exactly. Or another way is to consider the numbers that multiply together to be 80. So for instance, 1 times 80 is equal to 80. 2 times 40 is equal to 80. We're finding the factors of 80 here. 3, no. 4 times 20 is equal to 80. No, we're getting close here though, because 20, it's close. 5, because it's a multiple of 5, and then we can get our calculator and do 80 divided by 5 on the calculator, and you'll get that that's equal to 16. Now 16 then is a factor of 80, and 16 is between 11 and 19. So that's it. So 16 is a factor of 80 between 11 and 19. And that's it. Just to show you here then that 6 no, 7 no, 8. 8 times 10 would also be equal to 80, but they're not between 11 and 19. So 16 is the only answer here. And that's it. And as I said, you could have taken the 80 and divided it by 11, 12, 13, 14, 15, 16. And when you get to 16, you get the answer of 5 in your calculator. So that means that 16 is a factor of 80. Okay, let's look at our next question, question number 18. So question number 18 says, Beth writes down two numbers, and the numbers are factors of 42 and have a difference of 15. Write down the two numbers. So let's find the factors of 42. So 1 times 42 is equal to 42. So 1 and 42 are both factors. It's even, so 2 times 21. So 2 and 21 are both factors of 42. Okay, let's try 3. Well, 4 plus 2 is equal to 6, and 6 is a multiple of 3, so that means that 42 is divisible by 3, so 3 times, and if we do 42 divided by 3, let's see what we get. How many 3's go into 4? 1, remainder 1. And how many 3's go into 12? 4. So that's equal to 14. So 3 times 14 is equal to 42. So there are another two factors. And then 4, well, we can half it as 21. Half that again, no, that's not going to be a whole number. So it's not divisible by 4. 5, no, it doesn't end in a 5 or a 0. 6. 6 times 7 is equal to 42. And we're done. So the factors of 42 are 1, 2, 3, 6, 7, 14, 21, and 42. So they're the factors of 42. Now, Beth's written down two of them, and they've got a difference of 15. That means when you take them away, the answer is 15. So if you have a look here, 21 and 6. 21 take away 6. 21 take away 6 is equal to 15. So that means that 6 and 21 are both factors of 42, and they've got a difference of 15. And just checking, no, I don't see there's any other options, so that's it. So 6 and 21. Okay, let's look at our next question, question number 19. So question number 19, we've got these numbers, 2, 3, 8, 9, 11, 12, 15, and 18. We've got even and odd, multiple of 4, not a multiple of 4, prime, not a prime. And we've been asked to sort all the numbers into the correct boxes. So let's start off with 2. 2's even, and it's not a multiple of 4, so it's going to go there. 3, so we've done 2. 3, it's odd, and it's prime, so let's put it over there. We've done 3. 8, it's even, and it's a multiple of 4, so let's put it over there. 9, it's odd, and it's divisible by 3, so it's not prime, so 9's going to go there. 11, 11's odd, and it's prime, so it's going to go there. 12, 12 is even, and it's a multiple of 4, so it's going to go there. 15, it's odd, and it's not prime, so it's going to go there. And then finally 18, 18 is even, and it's not a multiple of 4 because it's not in the 4 times table, so it's going to go there. So that's it. We've got 8 and 12 here that are even and multiples of 4. We've got 2 and 18 that are even but not multiples of 4. We've got odd prime numbers here of 3 and 11, and odd numbers that are not prime, 9 and 15. And that's it. Okay, so let's have a look at our next question, question number 20. So question number 20 says, a bus to Belfast leaves Antrim bus station every 25 minutes. And the first bus each day leaves at 7 a.m. And Darren wants to get a bus after 8 a.m. So 7 a.m. is too early for me. He wants to get a bus after 8 a.m. And the question says, what time is the first suitable bus? Okay, now in terms of this question, there's a couple of different ways in which you may approach it. One approach is to say, well, the first bus is going to leave at 7 a.m. So 7 a.m., that's the first bus. And then 25 minutes later will be 7:25 a.m. The next bus will be 25 minutes later. So number 25 will be 7:50 a.m., just adding on 25 minutes. Adding on another 25 minutes. Now, this is going to be the bus we're interested in here because it's going to be after 8 a.m. So adding on 10 minutes brings us to 8 o'clock, and then we've got 15 more minutes. That's going to be 8:15. So 8:15 a.m. So 8:15 in the morning. So that's the time of the first suitable bus. So that's one approach. Another approach would have been to consider the multiples of 25, which are 25, 50, 75, 100, and so on. And we're looking to find which bus is the first bus to leave Antrim bus station after 8 a.m. So this would be 25 minutes, that'll be 7:25, 7:50. This one here, 75 minutes. 75 minutes is more than an hour. It's 1 hour and 15 minutes. So 75 minutes is 1 hour and 15 minutes. So 1 hour and 15 minutes after 7 a.m. would be 8:15 a.m. and that's it. So what time is the first suitable bus? The first suitable bus is at 8:15 a.m. Okay, let's look at our next question, question number 21. Okay, let's have a look at our next question, question number 21. So I really like this question. We're told that Harry writes down a 4-digit number. So he writes down a 4-digit number, and all 4 digits are positive, so there's no zeros, and they're different to each other. And so all the 4 digits are different. And the first digit is a factor of 15, so the first digit is a factor of 15. The second digit is a factor of 21. The third digit is a factor of 11, and the fourth digit is a factor of 25. And the question says, what number did Harry write down? So what number did Harry write down? So let's start off by writing the factors of 15, 21, 11 and 25. So 15, that's going to be 1, 3, 5 and 15, because 1 times 15 is equal to 15 and 3 times 5 is equal to 15. 21, that's 1, 3, 7 and 21. They're the factors of 21. The factors of 11, it's a prime number, so that's going to be 1 and 11. And the factors of 25, that's going to be 1, then 5 times 5, so that's going to be 5, and then 25. So they're the factors of 15, they're the factors of 21, they're the factors of 11, and they're the factors of 25. Now, I'm actually just going to rule some out because it's a 4-digit number and it says the first digit is a factor of 15, the second digit is a factor. So we can rule out any of the factors that have got more than one digit, because if the first digit is a factor of 15, it can't actually be a 15, it can only be a 1, a 3 or a 5. So I'm going to cross off that. I'm going to cross off 21 because the second digit can't be 21, the third digit can't be 11, and the last digit can't be 25. Okay, so this is great because now if we have a look at this, let's actually consider the digits. So, okay, so I've just written down 4 boxes here. Okay, now I'm going to start off by looking at the third digit because the third digit is a factor of 11 and it can't be 11, so that means it has to be 1. So the third digit has to be 1. So we've done that one. Okay, now let's look at the fourth digit. It says here all 4 digits are positive and different, so we can't use 1 twice. So it means the fourth digit can't be 1, so it has to be 5. Okay, this is great. We've got the third digit and the fourth digit. Okay, so we've got the third digit and the fourth digit, 1 and 5. Now if we go back up here, well, we've used 1 already, and we've used 5 already. So we've used 1 and we've used 5. So that means actually the first digit has to be 3. And then we've used 3. So if we then look at the second digit, well, we've used 3, so that means it has to be 7. So that means that Harry's number is 3, 7, 1, 5. And that's it. That's the 3-digit number that Harry wrote down. Okay, let's look at our next question, question number 22. So question number 22 says a blue light flashes every 8 seconds and a red light flashes every 12 seconds and both lights have just flashed. After how many seconds will they both flash together again? So we've got here, the blue one flashes every 8 seconds. So 8, 16, 24, 32 and so on. And the red light flashes every 12 seconds. That's 12, 24, 36 and so on. And as you can see here, 24 is in both of the lists. So after 24 seconds, they'll both flash together again. And that's it. Okay, let's look at our next question, question number 23. So question number 23 says, Kelly's organising a barbecue and she needs bread rolls and burgers. So she's buying bread rolls and burgers for her barbecue. And bread rolls are sold in packets of 20 and burgers are sold in packs of 12. And Kelly buys exactly the same number of bread rolls as burgers. And the question is, what is the least number of each pack that Kelly buys? So she buys exactly the same number of bread rolls as burgers. So we're looking for a common multiple because she can either buy, in terms of the bread rolls, she can buy 20, 40, 60, 80, 100 and so on bread rolls because they come in packs of 20. In terms of the burgers, she buys them in packs of 12, so she can buy 12 burgers or 24 or 36 or 48 or 60. Fantastic. So we're looking for the least number. Now it has to be the same number. She buys exactly the same number, so that's going to be 60 because she can buy 60 bread rolls and 60 burgers, and that's the lowest number of bread rolls and burgers she can buy. Now the question says, what's the least number of each pack? So she'd buy 3 packs of bread rolls and she'd buy 1, 2, 3, 4, 5 packs of burgers. So that's 3 packs of bread rolls and 5 packs of burgers. And that's it. So we found the common multiple, or the lowest common multiple, of 20 and 12. But we wrote down the multiples of 20, we wrote down the multiples of 12. We found the first number that's the same in both of those lists, so that's 60, because that'd be this, because she buys the same number of bread rolls as burgers. So she buys 60 of them, 60 each. And then we figured out how many packs she'd need. She'd need 1, 2, 3 packs of bread rolls, and she'd need 5 packs of burgers. Okay, let's look at our next question, question number 24. So question number 24 says, find 3 different prime numbers with a sum of 40. So you want to find 3 different prime numbers that whenever we add them together, we get 40 as an answer. Now, what's interesting here is, obviously with prime numbers, you've got odd prime numbers and even prime numbers, or there's one even prime number too. Now, we're adding 3 numbers together. Now, if we do an odd number plus an odd number plus an odd number, that's equal to an odd number. So if we want these three numbers to add together to be 40, we want to have either one of them being even, because obviously an odd plus an odd is an even, and then plus an even will be even, or we want all three of them to be even. Now, it can't be 2, 2, and 2, so that means that we're going to have an odd number, and an even number, because we want to have an odd plus an odd, which is an even, and then plus an even to give us 40. So that just thought would be quite useful in terms of starting point. Now we want to find three different prime numbers, so let's write down the prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, not 21, 23, 29, 31, not 33, not 35, 37. Okay, so we've got our prime numbers here going from 2 up to 37, and I think that's enough. And I'm going to start by writing down 2, because I know that I want them to add together to be 40, so that means that I want them to be an odd, and an even. So I'm going to go for 2 being the even number, because that's the only even prime number there. Okay, now, in terms of adding together to be 40, well, that means the other two numbers need to add together to be 38. And I'm thinking 7 and 31, so 7 and 31, because 7 plus 31 is 38, plus 2 would be 40. So 7, 31 and 2, and 2 plus 7 is 9, plus 31 is 40. So those three numbers, they're all different and they're all prime numbers, and they have a sum, they add together to be 40, and that's it. So that's what I've gone for. Okay, let's look at our next question, question number 25. So question number 25 says Georgie wrote down 3 positive whole numbers. So you write down 3 positive whole numbers, and the first number is a factor of 38. So let's write down the factors of 38. So it'll be 1 and 38 and 2 and 19. So they're the factors of 38. So one of them is a factor of 38. So one of her numbers that she writes down is one of these 4. And the other two numbers are both even and equal. So there's a number, and then there's another number and another number. So there's 3 numbers. These two are both even and equal, and then there's another one. And the sum of the 3 numbers is 31. So when we add them together, the answer is 31. Okay, so let's find what these numbers would be. So let's consider, well, we're not going to choose 38 because we want them to add together to be 31, and they're positive, so there's no negative numbers here or anything. So 38 is not going to be one of our options. Let's try 19. So if 19 was one of them, so if we had 19 here, then we would want 2 numbers here and here that they're both the same and they're both even, and they would add together with 19 to give us 31. So let's work out what these numbers would be. So let's take 31 and take away 19, which is equal to 12. So that's 12. And then if we take 12 and divide it by 2, that's equal, divided by 2, that's equal to 6. So it's going to be 6 and 6. And to check that, 19 plus 6 is equal to 25, plus 6 is equal to 31. So that's it. So they're the 3 numbers. We actually found it out quite easily there by our first attempt, really, of choosing numbers. And that's it. So the 3 numbers are 6, 6, and 19. And just to show you that if you had tried other numbers, I'm just going to show you, we got quite lucky there in terms of our first attempt. But if we hadn't have chosen 19, and we had chosen, instead of 19, we tried 2, then these two numbers would have to add together to be 29. And if you have 29, that's 14.5 and 14.5. They're not whole numbers, so that wouldn't work. And if this number was 1, then that would leave, well, these two numbers would have to be 15 and 15. But we're told they're both even, so it can't be 15 and 15. So that's it. So the answers had to be 19, 6, and 6. And that's it. Okay, so question number 26. Question number 26 says to write down a number with exactly 4 factors. Okay, so I've just written down a number here and factors. So let's start off writing down some numbers. So 1, the factors of 1 are just 1. So no, it hasn't got 4 factors. 2, the factors of 2 are 1 and 2. So no. 3, that's 1 and 3. 4, the factors of 4 are 1, 2, and 4. That's got 3 factors, not 4 factors. 5 is just 1 and 5. 6, the factors of 6 are 1 and 6, and 2 and 3. So 1, 2, 3, and 6. So 6 has got exactly 4 factors. So 6 would work. So 6 is a number with exactly 4 factors. Other numbers that I can think of are 10, for instance. So 1 times 10, so 1 and 10, and 2 and 5. So the factors of 10 are 1, 2, 5, and 10. 14 would work. 1, 2, 7, and 14. Even if you scroll up here, 38, we had a 1, 2, 19, and 38. That has 4 factors as well. So in terms of a number of exactly 4 factors, you could choose 6 or 10 or 14 or 38 and so on. So as long as the number has exactly 4 factors. Okay, let's look at our next question, question number 27. So question number 27 says, Theo thinks of a 4-digit number that's less than 7,000. And the number is a multiple of 9. Write down a possible number that Theo could have thought of. Okay, so this is a calculator question, so you could just type in a 4-digit number and divide it by 9. And if it comes up as a whole number, for instance, if you choose a number such as 1,476 and you divide that by 9, you get an answer of 164. And because that means that 9 goes into 1,476 164 times, it goes in exactly without a remainder, that means that 1,476 is a multiple of 9. It's divisible by 9, so that means it's a multiple of 9. So that's one possible option, 1476. And you could choose any 4-digit number that's less than 7,000, and as long as it's divisible by 9, and you can use your calculator to help you, then you can find a number that would work. And I also just want to show you the divisibility test, that if a number is divisible by 9, and if it's divisible by 9, remember, then it's a multiple of 9. So for instance, if we chose 5,550 something, and we wanted to work out the last digit here, so that's divisible by 9, let's figure out what that would be. So if a number is a multiple of 9, the digits will add together to be a multiple of 9. So for instance, 5 plus 5 is 10, plus 5 is 15. These three digits add together to be 15. Now we want it to add together to be a multiple of 9. Now if that's 15, if this was 3, 5, 5, 5 and 3 will add together to be 18. And that's in the 9 times tables. So it means that this number, 5,553, is divisible by 9. Okay, let's try another one. So if we had 1, 1, 2, what would the next digit be? So 1 plus 1 is equal to 2, plus 2 is equal to 4. We want a number that's a multiple of 9, so I'm going to go for 5, because 1,125, the digits add together to be 9, that's a multiple of 9, so it means that that number is divisible by 9 as well. So even if we went a bit bigger, you could go something such as 6,890 something. Well, 6 plus 8 is equal to 14. Plus 9 is equal to 23. So we want a multiple of 9, so I'm thinking 27. So let's try 4. So 6,894 would be a multiple of 9. And that's it. And that's it. So all of those numbers would work. Okay, let's look at our next question. Okay, so question number 28. Question number 28 says, Jessica says there's more prime numbers between 30 and 40 than there are between 40 and 50. Is Jessica correct? Explain your answer. So let's write down the prime numbers between 30 and 40. So between 30 and 40, the prime numbers would be 31 and 37. And here to find these numbers, these prime numbers, you could write down the numbers from 30 to 40 and then cross off any even ones, cross off any multiples of 5. You've got your calculator as well, so you can check and see if the ones are divisible by other numbers. But the prime numbers between 30 and 40 are 31 and 37. And between 40 and 50, so between 40 and 50, the prime numbers are 41, 43 and 47. And again, you could write down the numbers between 40 and 50, cross off any even ones, any that are divisible by 3 or by 5 and so on, and you'd be left with 41, 43 and 47. Now Jessica says there's more prime numbers between 30 and 40 than there are between 40 and 50. Well, no, she's not correct. There's actually more between 40 and 50 than 30 and 40. So let's write that down. And that's written, no, there are more between 40 and 50, 3 of them, than between 30 and 40, 2 of them. And that's it. Okay, let's have a look at our next question, question number 29. So question number 29, Peter says that all even numbers greater than 2 can be written as the sum of 2 prime numbers. I think Peter's been reading Goldbach's conjecture. And the question says, give 3 examples to show that Peter's correct. Okay, so let's choose an even number greater than 2. So for instance, 6. 6 is equal to 3 plus 3. And 3 and 3, they're both prime numbers. It doesn't say how they have to be different. So 3 plus 3 is equal to 6. So that shows that Peter's correct. So that helps show that Peter's correct. Let's try another one, 8. 8's equal to 3 plus 5. So 3 plus 5 is equal to 8. Let's try another one, 12. 12 will be equal to 5 plus 7. So that would work as well, 5 plus 7. And that's it. So 5 plus 7 is equal to 12. So these are all examples to show that Peter's correct. And that's it. And that's it. So these have been the video solutions to the Corbettmaths practice questions on multiples, factors and primes. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.